Hello YouTube! It's all things technical. Today I am going to be teaching you how to subnet Class C addresses. This tutorial will showcase a type of problem that you might encounter on the Network Plus certification exam. Let's begin. First, we begin by looking what the original IP address is. For this problem, the original IP address is 192.168.1.0, otherwise known as /24 in slash notation. The default subnet mask is 255.255.255.0 because it is a Class C address. The teacher in this example wants to add 9 new subnets and 13 hosts. The student is asked to answer these questions. What is the new subnet mask? What is the new subnet mask in slash notation? What are the new subnet mask ranges? For each range, what is the broadcast address and what is the network address? What is the maximum number of hosts that can exist on each network? Let's start off with the first and second question. What is the subnet mask and what is the subnet mask in slash notation? Since it is a Class C address, we are working with the last 8 bits in the 4th octet. The first 24 bits are already being used in the original subnet mask. Every time I work on a subnetting problem, I draw out the table presented below. N stands for networks, H stands for hosts. Under each individual bit in the 4th octet is what the slash notation would be if we stole up to that particular bit. To get 9 new subnets, we must steal bits from the 4th octet. Since we want 9 new subnets, we look at our table and find where n is greater than or equal to 9 networks. So 16 would be where we would find this value, because 8 isn't greater than or equal to 9 networks. 16 is. So we circle that, and to the right of it we draw a line. Circled in red shows how many subnets and hosts we could have if we stole 4 bits from the 4th octet in this problem. To get our new subnet mask value, we must add the stolen bits. 128 plus 64 plus 32 plus 16 is equal to 240. We get that from this line right here. Our new subnet mask will be 255, 255, 255, 240. In slash notation, that would be /28. You could see that right here. If you're confused on this, refer to the table. There are 32 bits in the IPv4 address. We started with a subnet mask in slash notation of 24 because it is a Class C address, which means we have 8 bits to work with. With that, let's move on to question 3 and 4. The next two questions deal with subnet ranges in each subnet's network and broadcast IDs. Always start off by filling out the network ID column first. For the Networking Plus certification exam, start with the original IP address, 192.168.1.0. For the next 15 columns, we will change the 4th octet value by the block size. You get the block size by doing 256 minus the new subnet's 4th octet value, which is 240. Remember, we stole 4 bits from the 4th octet in this problem, which adds up to 240. 16 is the number we will add in each column until we reach the max number of networks with our new subnet values. On the right side is the broadcast ID. Use the next subnet ID's 4th octet value and -1 to get the previous subnet's broadcast ID. The usable host range is easy, because it is the range of addresses between the network and broadcast ID. Remember, always start off with the network ID and add by the block size, which is 16 in this case. I did not list out all 16 subnet ranges, but I hope you understand how to get the remaining ranges between 192.168.1.96 in the final range. If not, please ask any questions you have in the comments below. The last question asks what the maximum number of hosts that can exist on each network is. This is easy. The formula is 2 to the h minus 2. In this case, we stole 4 bits, so we have 4 remaining bits for host addresses. 2 to the 4th minus 2 is equal to 14. We do -2 because the network and broadcast address are not usable hosts in each subnet. Again, for the network certification exam, we do -2 for the hosts. Please let me know if you have any questions in the comments below.